Hello and welcome to Carbony's Climate Talks. In the upcoming episode, I talked to Simon Manley, the head of carbon of Undo. The episode was recorded before the official launch of Undo, the new affiliate of the Future Forest company. Undo was co-founded by the Future Forest CEO, Jim Mann. Undo is focusing on carbon removals by using the technology of enhanced weathering. Nevertheless, also the afforestation activities of the Future Forest company are still active. With Simon, I talked about the technology of enhanced weathering, what it's about, how does it work, and what can it contribute to help the world to become carbon neutral. Enjoy and let us know in the comments what you think. Welcome to a new episode of our podcast show, Climate Talks, powered by Carbony. Today with a new guest, Simon Manley. A very warm welcome and thank you for being our guest.
Thanks very much for having me.
So Simon, in the previous episode with Andreas Jäger, who is like a climate activist, we were also talking about several technologies to remove carbon. And so I think you're the perfect guest today to talk about enhanced weathering. But before we get into this, I would kindly ask you to quickly introduce yourself. What is it that you are doing, with which company? And then we will get started from there.
Yeah, no problem. So my name is Simon Manley. I'm the head of carbon for the Future Forest company. And we are, you could describe us as a carbon dioxide removal project developer. So we implement projects around the world, currently out of the UK and the United States, which remove carbon from the atmosphere. And we use those projects to generate carbon removal credits, which we then sell into the offsetting market.
Okay. Cool. You know, I'm really a bit jealous of your title, Head of Carbon. Yeah, it sounds, first of all, very nice and neat, but could you also explain what is your daily business? What is the Head of Carbon responsible for?
So we kind of sit in the middle of, so I run our carbon team, and our carbon team sits in the middle of the projects on one side and our commercial team on the other. And so our job is to make sure that the physical operational activities taking place on the ground transition into tradable carbon assets. And what that means is that we need to take the projects through the certification processes laid down by the carbon standards, so the protocols, methodologies, standards, whatever you want to call them, to ensure that we are generating carbon credits, full stop, but also carbon credits that are high integrity, high quality, future-proof, and of the highest quality possible for the burgeoning sort of customer base in the offsetting market.
And I do believe this is also something that makes you guys at Future Forest company quite special, because, you know, in the market, when I talk to people and we talk about compensation, which is like a bad word nowadays, but I always need to explain like what is the difference between avoidance projects and high quality carbon removals. And so I think you guys are really positioning yourself on the side of high quality removals, correct?
Yeah, so I mean, there's avoidance versus removals, and then there's high quality removals. The best way that I have heard it explained to me is if you think of the atmosphere as a bathtub filling up with water, and the water is CO2. Okay, and so in the old offsetting world of compensation, it was okay to stop the bath filling up with water. In other words, you could just turn the tap off and keep the water or the CO2 at a level which was going to mean that we avoided climate disaster. Unfortunately, no one really listened, and the water continued to fill up, and now the bathtub is too full. And so it's no longer sufficient to turn the tap off. We have to pull the plug out to get some water out of the bathtub, in other words, some CO2 out of the atmosphere. Mm-hmm. And so carbon compensation or carbon avoidance and reduction projects such as photovoltaic cells or wind turbines, etc., that's the same as turning the tap off, but it's projects such as enhanced weathering or biochar or afforestation. Those are projects that are in this analogy, pulling the plug out and actually getting that carbon out of the atmosphere and getting us down to a level where we will hopefully avoid that temperature increase of 1.5 or 2 degrees centigrade.
Okay, so this is the difference between avoidance and removals. And then you said there's
That's right.
another step to high quality removals, which is like focusing on integrity. There's no double accounting. All
Yeah,
those.
that's right. So quality or best practice in this market is evolving very, very fast. You know, there's huge growth in this sector at the moment, and the kind of the best practice guidelines are. It feels like they're constantly playing catch up with all of the innovation and growth that's taking place in the marketplace. But most organisations will lean into the existing standards that exist that ensure that yes, that that the credits being generated from projects are high integrity, they're unique, they're authentic, and also, yes, indeed, that there are sort of robust carbon accounting systems in place to ensure that there's no double counting, no double claiming. And so what buyers are purchasing and utilizing to try and meet their net zero commitments are as high quality as possible.
Mm-hmm. Okay,
and that's important because of, sorry to interrupt, that's important, but not only because it's important to do the right thing and to do this correctly, but also there's huge reputational risk associated with the purchase of credits and then the claims associated with them around meeting your net zero commitments.
So let's say customers or companies who are looking for those high qualified removals, they have a long-term benefit out of it. Not only that they remove and do something good, but actually there's let's say much less reputational risk that they are actually putting on themselves, because as we know, by 2023, all those avoidance projects, according to the new CSRD directive, will be very problematic. So I have the feeling that the whole system or the whole sustainability market is moving towards those high quality removal projects.
That's certainly the case from a reputational perspective, but it's also the case from a net zero perspective as well, because in order to reach a net zero commitment, you need to neutralize your residual emissions. And so you can only do that through carbon removals. You can't do that through carbon avoidance. So eventually, as we get nearer to the deadline set by organizations to meet their net zero commitments, then carbon removals will become the primary offsetting product.
Just for our listeners, residual emissions are emissions that you cannot reduce anymore because you're a company doing business. This is something that will always remain there, no matter what activities you perform.
So you mentioned reputational risk earlier on. I mean, there's reputational risk associated with the quality of the credits that you're buying, but there's also huge reputational risk associated with your abatement strategy. In other words, to what extent have you managed to decarbonize your operations? And obviously, organizations need to do that to the fullest extent possible, such that, yes, that's right, that there are residuals. In other words, what's left over, you can't not produce any carbon. Otherwise, you'd just be standing still with the lights turned off. You've got to do something. And so those residual emissions need to be obviously as minimal as possible, because you have successfully decarbonized as much as possible. And then that's what you then need to neutralize through the purchase of removal credits.
Perfect. And one of the techniques that you guys are focusing on is enhanced weathering. Whenever I bring up this topic, then people say, yes, I know biochar, but I never heard about enhanced weathering. So my question to you would be now, what is enhanced weathering and how does it work in very simple explanation, simple terms?
Enhanced weathering is like it's one of the oldest carbon dioxide removal technologies that nobody's heard of. It's been happening for millennia. It's the acceleration of the reaction between CO2, rainwater, and certain types of rock. So as rain is falling through the atmosphere or through the air, it collects CO2. And when that rainwater hits certain types of rocks, silicate rocks, it kicks off a chemical reaction which releases cations and bicarbonates. And those bicarbonates then eventually stay in the water and eventually end up in the oceans, where they solidify. That carbon is then precipitated in solid form into the oceans. And in that way, it is that the carbon is effectively stored for hundreds of thousands of years. It becomes extremely stable. And so if you're thinking it from a cyclical perspective, the CO2 from the atmosphere captured by the water through rain hits the rocks, is kind of stabilized in bicarbonate form, but then is locked away when it becomes a solid matter in the oceans.
Mm-hmm. And those silicate rocks, are they like natural rocks, or is this something that is synthetic, or how can the listeners imagine this?
Yeah, they're completely natural rocks. They exist. There are huge deposits of silicate rocks all over the world. In fact, if it is predicted, or academic papers suggest that 430 billion tons of CO2 could be removed from the atmosphere through global silicate reserves. I mean, that's unlikely because that would require all of the silicate reserve to be utilized in this way. But that gives an indication of the extent of this particular resource globally.
Yeah, I mean, sorry, go ahead. On. No, please you.
The enhanced bit is, so I described the chemical reaction that is happening all the time when precipitation or rain comes into contact with this certain type of rock. But it happens very slowly. And so the way to kind of speed that up and therefore have a meaningful impact on carbon removal and climate change is to increase the surface area of the rocks and therefore increase or accelerate that chemical reaction that I've described. And the way that you do that very simply is just by taking the rock and smashing it up into smaller particle sizes and then spreading it out, typically on degraded agricultural land, so that reaction can happen faster and more carbon dioxide can be removed from the atmosphere.
So this is within the enhanced weathering. The enhanced part is basically this crashing the rocks, enlarging the surface area and spreading it on the field, or how can I imagine it?
That's exactly right. Yeah. So, and in so doing, what you're doing is you're accelerating a natural process. You're accelerating a process which is proven. It's been happening for millennia. And so you're enhancing it or accelerating that chemical reaction by doing just what you described.
Okay, as you said, since it's very important that to get a beneficial effect for the climate, we need to scale this, right? How are you guys doing it? Like, maybe you can take us a little bit through this process, like of owning the land or buying the land, or do you work with third-party suppliers that are landowners, and who's bringing out the rocks? Because I imagine this is like kind of a very tough and manual work.
So we consider it to be a very scalable technology. It's scalable because, like we've already established, there are huge deposits of silicate rock all around the world that are relatively easy to get access to. And therefore it is a gigaton scale. So when I say CDR, I mean carbon dioxide removal, right? So it is a gigaton scale CDR technology in terms of its total potential. Secondly, it's scalable because of the low implementation costs. So it's a relatively straightforward process to get access to the rock, get it to the right particle size, or get hold of it at the right particle size, then to spread it onto land. And so the upfront costs for implementation do not require you to, develop technology that doesn't exist yet, or develop some kind of sort of technique which needs to be tested over many years to be proven out. So the financial barriers to getting a project implemented are relatively low, and therefore it can be rolled out pretty quick. Of course, you've got to get access to the rock and you've got to get access to land. And our strategy at the Future Forest Company is to do that through partnerships with, we could call it rock owners or feedstock owners, which tend to be sort of quarries and the large aggregate companies, and then landowners where there is an increasing amount of degraded agricultural land due to the overuse of chemicals through industrial agriculture. And that's where we'll be spreading the rock in order to deliver that CDR function.
Mm-hmm. Okay, understand. In another talk, I was coming across the topic of geo-engineering, and before you were bringing up that this technique of enhanced weathering or weathering is happening for millennia. Where would you locate this technique of enhanced weathering? Is this a nature-based solution, or is it an engineered solution, or is this already geoengineering? What is your opinion on that?
I don't think it's geoengineering. The carbon dioxide, there's only a handful of kind of recognized carbon dioxide removal technologies, and they are broadly split into nature-based solutions, as you have said, and engineered solutions. Now, nature-based solutions, probably the easiest one to understand is planting a tree, and we all know how that sort of removes carbon from the atmosphere through photosynthesis. Now, nature-based solutions tend to be the enhancement of natural processes, so photosynthesis, but also they tend to be slow, quite unstable. If you think of the carbon stored in a tree, you only have to think of the wildfires in California or Australia to understand that that carbon can quite easily be released back into the atmosphere. However, they do deliver co-benefits, which we should talk about in a minute in terms of what the co-benefits of enhanced weathering are. Then on the engineered side, you have the process tends to be, well, relatively high cost. The carbon removal is immediate rather than it happening over, let's say, the life cycle of a tree, for example. Yeah. The carbon it's stable. In other words, the carbon is stored away for a very long time quite safely, but it doesn't tend to focus on co-benefits, the engineered solution side. Now, enhanced weathering kind of has the benefits of both. So if you were to imagine a Venn diagram with nature-based solutions on one side and engineered solutions on the other, right in the middle of that Venn diagram would be enhanced weathering, because it is immediate in terms of its carbon removal function. It's extremely stable. In other words, and we like to use the word durable, the carbon dioxide is locked away for hundreds of thousands of years. So it has all of the benefits of the engineered side, but at the same time, it's a natural process, and it delivers significant and important co-benefits, such as improvement of soil health, soil structure.
Mm-hmm. And because it's of this ideal nature, this is why you guys chose to do it and go for it and scale it, big time, right?
For all of the reasons that we've been talking about. So we believe it is, of the small group of the optimal carbon dioxide removal technologies, we believe it to be the best for reasons of scalability. It's relatively easy to implement, and it delivers the benefits not only from a carbon dioxide removal perspective, but also the co-benefits as well. But it's important to stress there is no silver bullet here. It would be completely wrong of me to suggest that the climate crisis will be sorted out through enhanced weathering. We need to do everything all at once right now. But we believe that, certainly from our commercial focus is concerned, enhanced weathering is where we are sort of targeting most of our activity.
Give our listeners, please, an understanding of how much CO2 can be captured by 1 ton of this silicate rock that is distributed on a field, approximate to the sea, or I don't know, wherever you guys bring it out.
So we're spreading it on degraded agricultural land. It doesn't necessarily need to be near the sea, but it does need to be in areas where there are certain climate conditions which mean the weathering process can take place, rain being the most obvious and important.
Just there in the UK, right?
Well, there's plenty of it in the UK, certainly, yeah. and within the UK, we're just beginning to get operations going in Scotland, and so there's even more rain in Scotland, and in terms of in the whole of the UK, it's a very rainy part.
Yeah.
So remind me of the question that you just asked. Sorry.
So how much CO2 can 1 ton of rock capture? Actually, how much can it remove out of the atmosphere? In ideal case, let's say.
Yeah, it depends on the type of rock. So there are different sort of types of silicate rock which are good for enhanced weathering. You've probably heard of olivine, and there's also basalt. We focus primarily on basalt for reasons that we can talk about in a minute. And so you tend to have anything between sort of 3 and 5 tons of rock will typically remove 1 ton of CO2 from the atmosphere.
Mm-hmm. Okay, and this is a one-time removal, right? You would spread this 3 to 5 tons, and then it's immediately capturing the CO2 once it's raining, right? Once this chemical process is starting.
Yeah, the weathering takes place over a certain time frame. So the weathering starts immediately that the rock goes onto the ground and it starts raining. However, the weathering process. So if you just take a certain volume of rock, for example, you could say, okay, that's the total sequestration or carbon removal potential is, let's just say, 1,000 tons. Now, that 1,000 tons of CO2 is not going to be taken out of the atmosphere just like that. It'll happen over a period of time. And depending on the structure of your project, so there are all sorts of different sort of variables and parameters, you can, it's called a weathering curve. And so the weathering happens over a certain timeline. And anything between sort of 10, 20, 50, or even 100 years, depending on how you've structured your project.
Mm-hmm. Maybe you can give us now some details on what are the co-benefits and the risks of those enhanced weathering, because for sure I can imagine when this is applied on agricultural land, maybe there are some benefits even for biodiversity, for the fertility of those soils. So,
well, first of all, the risks. So the biggest risk associated with enhanced weathering is what's in the rock. And so certain types of rock, and typically olivine and not basalt, can contain heavy metals. And so given the fact you're putting this stuff on the soil, you don't want those heavy metals to go into the soil and therefore contaminate it for perhaps future agricultural use. So if that land is being used to produce food or indeed to grow trees, then you don't want to contaminate it with anything like sort of heavy metals. And so it's super important that you have a full understanding of the chemical and mineralogical breakdown of the rock itself before applying it, because you don't want it to contaminate the area that you're applying it to. So that's the primary risk. In terms of the benefits, well, and this again brings the focus on why we prefer basalt rather than olivine, is because basalt contains important nutrients which actually sort of benefit the soil, potassium and phosphorus, for example, as well as some other sort of micronutrients as well. Now, so these can add significant benefits in terms of soil fertility, but also just the physical material itself improves soil structure, improves drainage, regulates soil humidity. And so in terms of putting it down onto degraded agricultural land, it can bring it a little bit closer to being back into productivity as the sort of the soil benefits are delivered.
Okay. And so you guys are getting those rocks from UK, from local supply, or maybe you can take us a little bit into your supply chain and how this is working, how you're scaling this up. Like you're searching for project partners, and those are then the ones who distribute it on the land, correct? And
yeah, we're moving towards at the moment, during the phase that we're in at the moment, we are operating or we're active in most elements of the value chain or the supply chain. But we are rapidly moving towards a point where we have a partnership model. So we'll be working with third parties who are already operating in the areas that we want to. In other words, they've got access to the rock. They're already crushing it up because a proportion of it will be utilized for sort of aggregates and as aggregates for road building, etc. And then we also want to work with landowners and agricultural contractors as well, who again have the infrastructure and the land in order to spread the rock. So it's a partnership model that we're working towards. And the piece that we bring in is all of the expertise and know-how around sort of, making into reality the actual carbon dioxide removal, recording all the data from the projects, accounting all of that in a credible and transparent way, and then the generation of the carbon credits for us and obviously project partners as well.
And what are the possible feedstocks for enhanced weathering?
Well, it comes back to the different types of silicate rock. So, I've mentioned olivine and basalt probably being the most highly utilized and best known.
Okay, good. And now so we had a little technical deep dive on how enhanced weathering is taking place. I would put myself now in the shoes of a potential customers of yours. Okay, let's say I call the Future Forest company. I am a company who has already calculated the footprint. I have reduced what I can. I have this residual emissions. And what am I getting now from you guys? I suppose you will give me credits, and how are those validated and verified? Because whenever I talk to companies, this is very often the moment of doubt, let's say, where people are, okay, but how can we prove this, and how how is it possible that we can add this to our ESG report?
Sure. So at the moment, there is no internationally recognized methodology or standard for the quantification, the verification of carbon dioxide removal from enhanced weathering. Thankfully, in-house, we have the expertise to develop a methodology, which is exactly what we're doing. And so we're in the process at the moment with we're in the process of working with third parties to write and develop a methodology that will enable that. In other words, the quantification and verification of the CDR function of enhanced weathering. And that methodology will then be sort of validated, and then in turn the projects verified by sort of credible independent third parties. And eventually, in time, that methodology will be ECROA-backed. In other words, approved by the industry best practice body, and will hopefully sit within the methodology portfolios of organizations such as the Gold Standard and Verra, the Climate Action Reserve, and other sort of well-known and sort of best practice carbon standards.
And this is what you guys are working towards too with your methodology, right? Like this is
right.
The ideal goal.
Yeah, and again, that comes back to what we were talking about at the beginning of the conversation around quality. So buyers need assurance that they're buying credits that are high integrity, high quality, durable, etc., and that assurance not only comes from the project type itself, and we've talked about why enhanced weathering delivers that kind of quality, but it also comes from the third party endorsement that these standards can deliver. And so it's super important to us that the recognized and credible standards have endorsed the methodology that we're developing.
And me still speaking as a customer now, I would receive a credit afterwards, and is it like that I would invest 100% in enhanced weathering, or would there be also other technologies, or is this a portfolio that you're offering? Just for me to understand better your business case and your products.
Our primary carbon credit product will be generated from enhanced weathering. So most of the carbon credits that we generate will be from enhanced weathering. We do have other projects and access to other projects that include biochar and woodland creation and peatland restoration. However, the majority of our credits will come from enhanced weathering activities, and that is where our commercial focus is almost 100% targeted at the moment.
Could I also, as a company, if let's say I'm a landowner, could I also become a partner with you, saying, since I have the land here in Austria, I would be interested to spread the rocks also on my ground, and maybe by doing so, sourcing also part of the removals that I need for my unavoidable emissions? Is this a...
Yeah, most definitely. And so if you can imagine the supply chain for enhanced weathering, starting with the sourcing of the rock, the processing of that rock to the right particle size, then the transport of that rock to the application site, then the land associated with the application site itself. Then if you operate in any part of that value chain, then yes, no, we would be delighted to speak to you about being a potential project partner, whereby we can deliver what I've described earlier on, and you would obviously benefit from some of the carbon removals to come out of that partnership.
Cool. Simon, before we end, I want to ask a more open and general question, because you already mentioned at the beginning, we kind of need to do everything right now, to really tackle climate change and not end up in catastrophe. What is your vision, or if you were in charge, let's say, what do you feel we need to do now, as we are in the industry, the private people, society? What are the next steps that we definitely need to do and that are kind of unavoidable at the moment?
That's a big question. We need to urgently decarbonize our economies to a massive scale, and put behind that effort considerable more energy, and talking about sort of energy from individuals and organizations, motivation, incentivization, legislation, regulation, to make that happen. And I don't really think it exists anywhere near to the extent that it needs to make that happen. And at the same time, we need to invest at a huge scale into the technologies that can credibly remove carbon from the atmosphere. As I said earlier on, we're no longer in a position where we can afford to turn the tap off. We have to pull that plug out, and there are only a few technologies that are proven to deliver that benefit. And so, if you look at the supply of credits, carbon removal credits that are on the market now, and you compare that to the current level of demand for those carbon removals as net zero targets approach, and then what that demand will look like in 6, 12, 18 months time, there's a huge disparity. There's so much more demand than there is supply. And so we urgently need to address that supply side and invest big scale into projects that can credibly deliver those carbon removals and at scale.
So in other words, what you guys are doing as one company, you can never, still the demand that will be out there, right? There needs to be also other projects. There needs to be much more investments to bring even more project developers on the road.
Well, I mean, we have an ambition to be the first company in the world to remove 1 billion tons of CO2 from the atmosphere through enhanced weathering activities. That's our ambition. That's our target. But even that will be just no pun intended, but a drop in the ocean, because as I'm sure you're aware, the world, we have to be removing 10 billion tons of CO2 from the atmosphere every year by 2050. And then after that, it goes up to 20 billion tons every year. So, I think our sort of objectives are ambitious, but they're achievable. But at the same time, we need lots of other organizations to be doing operate or to be delivering at a similar scale to really, make a difference.
What gives you hope when you look to the future? Why are you positive that we can achieve those things? What gives you the belief that we as the human race can do it?
I think self-interest. I mean, the human race is just massively motivated by survival instinct and self-interest. And so if we can create the right infrastructure and sort of motivation and incentives to actually sort of deliver sort of individual and organizational level benefit to actually sort of doing this work, then I think it's completely possible. We're extremely adaptable and innovative as a sort of species. So there's no reason why we can't do it. And there's absolutely no excuse. Nobody that's alive today can use the excuse that they didn't know it was happening. And so I think we are capable of doing it. We just need to have, like I said, the right motivation and regulation in place to make it happen.
But those regulations, you feel should there be some stricter rules from the lawmakers side, or because I also believe that we are capable of, but humans are very comfortable as long as they are not affected by direct results, and I feel that a lot of people are still, they don't need to see this because it's not directly affecting them, or it's not obvious that this is because of climate change. Where do you see the role of the politics in the upcoming years of bringing along, new standards, new regulations to really get also? I mean, we need to face this. The industries are let's say that the main polluters that need to get started first.
I'm not a politician or a lawmaker, so it's difficult for me to sort of be specific about that. That so much hope and optimism is generated around the conference of the party talks, the COP talks that take place every year. Just had one in Glasgow, for example. And while everyone delivers a little bit of progress, none yet have delivered that kind of game-changing sort of regulation that everybody hopes for. So there's this sort of collective optimism, and then sort of a similar level of sort of disappointment after each of these events. So yeah, I don't know what needs to be done specifically around the exact policies, but we've got the infrastructure in place to get everybody together to talk about it. But people need to be a little less self-motivated and get behind a collective effort.
Just as you guys are. Thanks a lot for your contribution, and thank you for being my guest today.
Not at all. It's been an absolute pleasure. Lovely to talk to you.
Thank you, Simon.